In Unit 9, we will be studying about the organic compounds containing nitrogen. This unit is divided into two parts. Part 1 is about amines and part 2 is about diazonium salts. In this unit, you will be studying about the day-to-day life substances in which amines are present, and then structure of amines, classification of amines, nomenclature of amines, methods of preparation of amines, physical properties and chemical properties of amines. Amines are the derivatives of ammonia obtained by replacement of one or two hydrogens are replaced by the alkyl groups or the aryl groups. Now here if you see in this slide, the examples of these compounds are given. When NH3 is the hydrogens of the NH3 are substituted by methyl group or benzyl group, or here if you see in this example, the two hydrogens are substituted by the methyl groups. Okay, so in the case of ammonia, it is NH3 and the hydrogens of NH3 are being substituted by the methyl groups, that is alkyl groups or aryl groups. If all the three hydrogens also can be substituted, such type of compounds also are formed. So such compounds in which the replacement of one, two or all the three hydrogens of ammonia are done by alkyl or aryl groups are called as the amines. Now what is the structure of amine? Just like the ammonia structure which you have studied in 11th class, if you remember, the structure of ammonia is on based on the Vesper's theory. It is explained on nitrogen there is a lone pair of electrons after it is bonded to the three hydrogens. Now because of this lone pair of electrons, the shape of the molecule is changing. Here it is, nitrogen is sp3 hybridized, and because of this sp3 hybridization, the shape of the molecule should have been tetrahedral, but because of a lone pair of electrons, what is happening? The bond angle is decreasing from 108 to 107 degrees in the case of ammonia. Now in the same case, in the same way in amines, the nitrogen atom in the amine is trivalent and it carries an unshared pair of electrons, that is a lone pair of electron, and the nitrogen's orbitals in amines are sp3 hybridized. But here the slight difference between the alkyl amines and ammonia is the bond angle. In the case of alkyl amines, due to the large size of the methyl groups, the bond angle is 108 degrees, whereas in the case of ammonia it will be less than that, because hydrogens are the atoms which are present. So because of this lone pair of electrons, the bond angle is 108, though the hybridization is sp3, and the shape of this molecule is pyramidal shape. Now coming to the classification of amines, amines are classified into three types as primary, secondary and tertiary amines. Primary amines, secondary amines and tertiary amines. Now primary amines means only one hydrogen of the ammonia is substituted by the alkyl group. Such compounds in which only one hydrogen is substituted from the ammonia by an alkyl group or an aryl group, it is called as a primary amine. If two hydrogens are substituted by alkyl or aryl groups, it is called as secondary amine. And if three hydrogens, all the three hydrogens of ammonia are substituted by alkyl groups or aryl groups, it is called as a tertiary amine. The amines also can be classified as aliphatic amines or aromatic amines. Aliphatic amines when the groups are alkyl groups, and aromatic amines when the groups that are bonded to the nitrogen are aromatic, that is benzene ring is bonded. Here, see here for example aniline, where the nitrogen of the amine is substituted by benzene ring, it is called as aniline. It can be the presence of both alkyl and aryl groups also, like N-methylaniline, which is a secondary aromatic amine. Then benzyl diamine, in which the benzene ring with CH2 is there, and then the nitrogen of the ammonia is substituted with the benzyl group. Then it is called as aliphatic amine here, because the nitrogen is substituted directly by 3 alkyl groups. Aromatic amines is amino group is bonded to benzene ring, and this compound is called as aniline. Aniline is the name of this compound, both in IUPAC system and even in common system. Aniline is used, and when there are substituents on the nitrogen of the aniline, then they will be named according to the substituents that are there on the nitrogen. If for example, if we see the first compound, there are 2 CH3 groups, and these 2 CH3 groups are substituted on the nitrogen of the aniline. Since the 2 methyl groups are present on the nitrogen itself, then the name of the compound is given as N-dimethyl aniline. And NH2 group present on benzene ring is called as aniline, and if the hydrogens of the aniline group on nitrogen are substituted by alkyl groups, then the name will come based on the number of alkyl groups that are substituted on the nitrogen, and N should be repeated because on nitrogen itself both the methyl groups are there. Now here coming to this third example, here this is aniline. Without the CH3 group, this will be called as aniline, benzene ring with NH2, but at the fourth position there is a methyl group. So in a IUPAC system of naming, it will be called as 4-methyl aniline, and in common system this position is opposite to the aniline group, so it will be called as para-methyl aniline. The nomenclature of amines both in common system of naming and IUPAC system of naming we will be learning now. In common system of naming, the alkyl or the aryl group bonded to the nitrogen is added as the suffix to the amine. That is, if there is methyl group, CH3 group, then this CH3 group is written first, methyl, and the amine is written as the suffix. Methyl is written first and the amine is written as the suffix. If ethyl group is there, then ethyl is written first and then the amine is written. If more than one are there, more than one groups of similar type are there, then it is written as diethyl, and here there is another group which is methyl group, methyl, methyl group, it is called as diethyl amine, diethyl methyl amine. In the alphabetical order, E comes first and then M, that is why ethyl should be written first and methyl should be written later. If 2 phenyl groups are there for the ammonia, 2 hydrogens of the ammonia are substituted by phenyl group, then it is called as di is the multiplicative prefix, and what are the groups? Phenyl groups are there and they are there for the amine. So it is called as diphenyl amine. In IUPAC system, the amines are named by writing the alkane. The alkane is written first, and from the alkane, the E is substituted. E is substituted, and in the place of E, amine is written. Okay, so it will be called as alkanamine. Alkanamine is written for amines which are having alkyl groups. The alkane's name is written first and then the suffix amine is given. E of the alkane is substituted by amine. Here for example there is CH3 NH2, so the name of the compound will be methane. E should be substituted by amine, so it is called as methanamine. And for ethane, E should be substituted by amine, so it is called as ethanamine. In IUPAC system, the alkane's E is substituted by the amine. So these are some of the examples of amines. The tabular column which is also given in the textbook. So if there is if on the amine group is present on the carbon chain, then the position is given. Like for example here the second one is propane 1 amine and the third one is propane 2 amine. If the alkyl groups are present on the nitrogen, the hydrogens are substituted, then we have to use the prefixes NN both in common name and IUPAC name. In common name we will be writing if two same groups are there. Here two same ethyl groups are there, so NN diethyl. Whichever is the longest chain, that will be taken as the main hydrocarbon, and the position from where the nitrogen is attached that will be given as the first number. So in common system it will be NN diethyl butylamine, and in IUPAC system NN diethyl butane 1 amine. Since the first carbon of the butane is having the nitrogen and the substituted nitrogen here, it is written as NN diethyl butane 1 amine. Now coming to the next part of the topic, methods of preparation of amines. There are 6 methods of preparation of amines. First one is by reduction of nitro compounds. Second one is by ammonolysis of alkyl halides. Third by reduction of nitriles. Fourth by reduction of amides. And fifth by Gabriel phthalimide synthesis. And sixth by Hoffman bromamide degradation. The methods of preparation, coming to the first one, nitrobenzene is reduced to aniline by either by catalytic hydrogenation in the presence of ethanol, or tin in the presence of HCl, or iron in the presence of HCl. In this method, the reduction of the nitro group is taking place and it is forming the amine. Now out of these 3 reagents, iron with HCl is preferred because here very small amount of HCl is required to initiate the reaction and further the reaction will continue. So this iron plus HCl is a better reagent for reducing nitrobenzene to aniline. Coming to the second method, by ammonolysis of alkyl halides. Now what is the meaning of this word ammonolysis? Is addition of ammonia to the alkyl group. Since addition of ammonia is taking place to the alkyl group, it is called as ammonolysis. In this method, the alkyl halide is treated with ammonia. So here in this process, when excess of alkyl group is taken, then only primary amines we will get, but if equal amounts of ammonia and alkyl halide is taken, we get a mixture of primary, secondary, tertiary, and also we get a quaternary ammonium salt. Quaternary ammonium salt means 4 alkyl groups are there, and if you see in this compound there is a it is a salt because of the presence of positive and negative charges. Okay, ammonium salt is formed, quaternary ammonium salt. So if we want only a primary amine, then we can do it by taking sodium hydroxide. If sodium hydroxide is treated with ammonium salt, then it will give only primary amine is formed. Okay, when the alkyl halide is treated with ammonia, and then this quaternary ammonium salt is reacting with sodium hydroxide, then it will give primary amine. Another next method of preparation is by reduction of nitriles. Nitriles means cyanides, and also by reduction of amides. In the presence of hydrogen, catalytic hydrogen, the nitrile is getting reduced to ammonia. In the presence of sodium amalgam and ethanol, amides also can be reduced into amines to in the presence of reducing agent like lithium aluminum hydride, followed by hydrolysis with water. The next method of preparation, the fifth method of preparation, is by Gabriel thalamide synthesis. Here thalamide, we have studied the formation of thalamide in the earlier unit, that is in carboxylic acids. When phthalic acid is treated with ammonia, it will give thalamide. So this thalamide on treatment with potassium hydroxide, it gives a salt of thalamide, which is further treated with alkyl halide. So here the reagent which is giving the alkyl group is alkyl halide. It is forming N-alkyl thalamide. Now this N-alkyl thalamide is next treated with the base aqueous sodium hydroxide, and it is giving a primary amine. So this reaction, Gabriel thalamide synthesis, is used for the preparation of only primary amines. This method is not suitable for secondary or tertiary amines because aryl halides do not give nucleophilic substitution reaction. Aryl amines, because this method is not suitable for primary aryl amines, that means only aliphatic primary amines can be prepared, but not aromatic amines, because aryl halides will not give nucleophilic substitution. If you remember, we have studied in haloalkanes and haloarenes, there is a partial double bond between the halogen and the benzene ring. Okay, due to this partial double bond, why this partial double bond is formed? Because of the lone pair of electrons on chlorine, it is forming a partial double bond. So since it is forming a partial double bond, there will be no nucleophile here. There will be no nucleophile here, so that it can form this reaction. That is, primary aryl amines cannot be given here. Okay, so because aryl amines cannot be prepared, primary aryl amines cannot be prepared because aryl halides do not give nucleophilic substitution. Here because of partial double bond, it will not form a nucleophile. That is the reason it is not able to form primary aryl amines by Gabriel thalamide synthesis. Coming to the last method of preparation, Hofmann bromamide degradation reaction. Now in Hofmann bromamide degradation reaction, an amide is treated with bromine in the presence of, now what is an amide group? NH2 group is called as amide. NH2 group is called as an amide. Now this amide, when it is treated with bromine in the presence of sodium hydroxide, it is giving a primary amine. Okay, this reaction is called as Hofmann bromamide degradation reaction. Since here CO is removed from the amide, that is why it is called as degradation, because there is decrease in the number of carbon atoms from the reactants to the product. Okay, this reaction is very important because many of the conversions which we will be studying in the amines are based on this Hofmann bromamide reaction. In this reaction, the decrease in this is called as descent of the series, because there is decrease in the number of carbon atoms, and the amine that is forming has one carbon less than the parent amide.